We've discussed the infrastructure portion of security. This time we're going to talk about the security from the perspective of the application developer. So the first question is what to protect? And the answer is data and resources, no surprises. So what kind of data are we talking about? We're talking about credentials. We're talking about sensitive data, whether corporate sensitive or personally identifiable information, or there's some data subject to regulatory controls. HIPAA is a U.S. Law that mandates certain types of protection on health data. There's also just contractual agreements. So the there's the data. If you're using credit cards, then PCI is the contract that you sign with the credit card people, and that requires you to protect things like credit card numbers and logins. Uh, how do you minimize the amount of data that you need to protect? Well, number one, don't collect it if you don't need it. Number two is encrypt it so that even if somebody breaks in and gets the data, um, they can't understand it. Uh, Number three, use data models and schemas that separate the critical information from other data. That lets you set different protection settings, different access rights for sensitive data. And do not expose critical data in logs. Don't save them in logs. Don't save them in cookies. What kind of resources do you want to protect? And why do you want to protect it? So there are two reasons. Uh, One is that if you're subject to a denial of service attack, then that would be through the resources. And so you want to restrict access to the resources as a way of protecting against denial of service. The other reason is if somebody accesses some resource and they're not entitled to, there's a possibility that they could then gain control of your system in a wide variety of different ways. And so what kind of resources do you want to protect? Well, the obvious ones, CPU, memory, disk space, and network access, but also APIs. Okay, and one of the discussion questions is why APIs? So I won't answer that. How do you secure web systems? That's a wide class of systems. Well, you sanitize the inputs at the client side and the server side. So there are attacks like buffer overflow, or SQL injection. So SQL injection involves escaping, putting escape characters in the query and then not unescaping it. So it gives you a very long input, which will lead to a buffer overflow. So if you sanitize the input, that means that you check and get rid of all these escape characters. Uh, you encode the request and the response. Okay, encrypt it. Uh, you use only the current encryption algorithms and hashing algorithms. So there's an organization in the US, the National Institute of Science and Technology, NIST, and they they test algorithms, they test implementations. And so they give you a list of currently approved implementations of various types. And again, don't store sensitive data inside cookies. Also, review your system uh, for uh, for security. So there, you can review it at the requirements level, and this review typically involves a security expert as well as the developers. So at the requirements level, an example is our potential adversaries identified explicitly. At the design level, there's something called the attack surface, which are the things that can be attacked by a malicious person or entity. Uh, so you define the attack surface, and usually it's network connections, and you look to make sure that those are secure in a variety, again, different ways. Uh, you use secure coding practices. Okay, there are books, secure coding in C, secure coding in C++, and so on. So there are some things that are known to be insecure and others that are known better practices. So you can have reviews. So again, discussion questions. Uh, Look up the PCI requirements, see what they are with respect to credit cards, with respect to the data, um, and then ask yourself why APIs should be protected. So let's move on to talk about the software supply chain. So what is it? So it is all of the libraries, code, hardware, and tools that take your code into an executable, or a final service, actually put the executable into production. Much of the software that you have on your system is not software that you coded. So the operating system, you take that. The middleware, you take that. API frameworks, you use standard API frameworks. Libraries, you use libraries that you didn't develop. And these are developed as open source or commercial off the shelf. And this software is all a portion of your supply chain. And also a portion of the supply chain are the tools and hardware that contribute to the production of your system. So Jenkins, for example, is part of your supply chain. If you're going to use open source software, which most projects do, then you need to evaluate them and decide whether the thing that you're going to choose is appropriately mature. So what happens is that people make things open source and then abandon it. They open source it because they don't want to work on it anymore for one reason or another. And so you look at the project maturity and development uh, activity. Is this product? Which systems use this product? Which vendors? Which yeah, vendors use this product? So that gives you some idea that the product is actively being maintained. Uh, can you identify the maintainers? Okay, so usually, if you look at the metadata associated with a project, it'll tell you who the active maintainers are, and these maintainers will contribute. So we'll talk about vulnerabilities in a minute, but what happens is a vulnerability is announced and somebody's got to fix it. If you don't have an active maintainer, then it's not going to get fixed. So you want to make sure you have active maintainers. You want to look at the repository that's being used. Is it one of the ones you recognize? Subversion is common, Git is common. Uh, uh, so if it's not a standard repository that calls the what the modernity, I don't know the word, uh, of the project into question. Is there a download confirmation hash? So open source software is mirrored at a variety of sites around the globe so that wherever you are downloading it from, there's a site that's relatively close. Well, these mirrors can be attacked. And so what happens is the creator of the software publishes on a different channel a confirmation hash. When you download it, you hash the download, you compare it to the confirmation hash. If they're not the same, there's a problem. This is done automatically by many tools, but that's still something that you want to check. And then who's funding the support? So a lot of times companies will open source products so they can get additional contributions, so they can get additional users, so they can have people from other companies work on it. Without running afoul of antitrust laws, and they assign their employees to maintain it, uh, and look and see which companies are funding it. That means there are active maintainers. Again, it's a way of determining whether they're active maintainers. So you want to make sure that the steps in your supply chain are trustworthy. And trustworthy is, they're signed in one way or another. That's cryptographic attestation. I can't say that either. Attestation and verification. So the various things should be signed by a certificate typically. You need to use automation. So your IA, your infrastructure as code scripts uh, are important in managing the supply chain. You know, so build environments used in a supply chain should be clearly defined, and access to them should be limited within your organization. So an easy way to introduce malware into your products is to arrange for, say, your build server, say Jenkins, to insert it. And so you want to restrict access to the build server. You want to, for example, notify other members of the organization when somebody changes the build server. Mostly it's benign. They introduce a new version, or they set the configuration levels, but you want to make sure that if they're doing something untoward, that other people are informed of it. And Kubernetes is a popular container management system. And so there are some special things you do to secure Kubernetes. And one of them is you scan the containers and pods for vulnerabilities or misconfigurations. There are scanners. And we'll talk again about vulnerabilities. Uh, you run containers and pods with the least privileges possible. So these things have privileges to do certain things. You want to make it as restrictive as possible in order for them to do their job. You want to put firewalls between in the network so you can control the amount of damage. If one of the Kubernetes containers gets compromised, you want to put in a firewall so that you can restrict with appropriate rules so that you can essentially isolate it. You want to use strong authentication and authorization, and we'll talk about that as well. And restrict administrator access. Uh, and then all these tools generate logs. We talked about logs when we talked about measurement. Audit the logs periodically. So have someone look at the logs and make sure that things seem to be operating as they're supposed to. And you periodically review the settings. So one of the attack is to change the settings. So you periodically review them, make sure that they are what your organization wants them to be. And then you use scanners. So a scanner is a tool that runs in the background, and it looks at all of there are different types of scanners, and they look at all the software in your system and check it for a variety of things. And we'll talk more about that in a minute as well. So discussion questions, again, offline. If you have a deployment pipeline and it's built with tools from multiple vendors, is that going to be more or less secure than if it's built with tools from a single vendor? What are the pluses and minuses of multiple vendors versus single vendors? Uh, Jenkins is a widely used CI server. Who supports it? Who funds the maintenance of Jenkins? And you can find this in the Jenkins metadata page. Okay, so let's move on to, I promised you I would talk about vulnerabilities. Well, now's the time. So there are things called weaknesses. A weakness is a coding practice that is potentially vulnerable. So for example, if you allocate memory and then do not allocate it in something like C, then that memory stays around. But it provides an avenue for a potential attack. Okay, and so there are lists uh, of weaknesses, and they're kept in a database, and the database is called the CWE, the Common Weakness Enumeration, and static analysis tools uh, use that as the basis for checking things. So uh, those are weaknesses, those are not vulnerabilities. A vulnerability is a specific weakness that has a known exploitation path. So somebody discovers a weakness, decides how to exploit it, and then it becomes a vulnerability. So vulnerabilities are enumerated in the CVE, not the CWE. So the CVE is the Common Vulnerability and Exposures Database, and we'll talk about the process of vulnerabilities in the next slide. So somebody discovers a vulnerability. That could be the organization that built the software. It could be some external individual. And assuming that they are uh, a good citizen, they report that to the CERT Coordination Center. And this starts what's called a disclosure window. It's currently 45 days. And the vulnerability is kept private. The existence of the vulnerability is kept private for that disclosure window. The vendor or maintainer is privately notified of the vulnerability, and the disclosure window gives them time to prepare a patch, and it gives them an incentive to prepare a patch before the vulnerability is publicly disclosed. Vulnerability is publicly disclosed and listed in the CVE. Uh, the current maintainer of the CVE is the MITRE Corporation, and it gets an identifier. The identifier is used to reference the vulnerability. It refers to a specific version, a specific release of that version of a piece of software, and a specific patch level. And the vulnerability is also entered into the U.S. National Vulnerability Database. The vendor issues a patch. Okay, and the patch is something to affect that to repair the identified vulnerability. This patch could be binary or it could be a code patch. And the patch is publicized by the vendor. And a link to the patch is placed in the NVD. And you, as a user, are informed of the patch either through monitoring of the vendor's mailing list. So you get on the vendor's mailing list and say, tell me about all the patches that you have put out, or you can monitor the vulnerability database, or you can have some sort of automated patch management service. And then you apply the patch. That's the model. And then you no longer have that vulnerability. The problem with this is there's too much information. So let's suppose you're using a Microsoft product. Well, Microsoft has hundreds of products. And if each product has a vulnerability, and not only Microsoft, Apple, I mean, all of the vendors, uh, if they have vulnerabilities, then they're going to be on their list and you're going to get mail. If you have products from multiple vendors, which is likely in your installation, then you're going to get an awful lot of vulnerability notifications. A way of managing that is to have a service that knows what software is running in your systems and monitors the vulnerability and screens them so that you're only informed of the ones that pertain to the software that's in your system. Another way of doing it is there's scanning software. If you'll recall, we talked about the SBOM at one point, the software bill of materials. And the software bill of materials ideally enumerates all of the software in your system. The scanner will look at your SBOM, look at the CVE, and see if there's a piece of software that also has an unpatched vulnerability. And you might say, well, we scanned before we checked that before we deployed. But the problem with that approach is that time passes. So when you deploy the piece of software, there may have been no known vulnerabilities. During the time between you deployed it and when you deployed it and say several months have passed, then a vulnerability might have been discovered. Excuse me, and that's the purpose of these vulnerability scanners. And then you have to so you know you have a vulnerability, you know there's a patch available. Do you want to apply it? Okay, so applying a patch can be disruptive. It's equivalent to putting in a new release because you apply the patch and you have to test it, then you have to rebuild the system, and then you have to deploy it. So it has to go through the standard pipeline and the gates, and that's essentially equivalent to making a new release. Sometimes, uh, so you have the option not to apply the patch, and it depends on how severe the problem is, how relevant it is to your operation, and so on. Some organizations rebuild their entire system frequently, so they don't have to worry about applying patches. They just take the latest release of any piece of software. Uh, so that's another option as opposed to applying patches. So discussion questions, again, offline. So what are the pluses and minuses of making vulnerabilities public? Pick a tool in your deployment pipeline. Look in the CVE to find a vulnerability. Check to see whether a patch has been issued. Check to see whether the patch has been applied to your particular installation. Okay, now we move on to authentication and then authorization. So authentication is the process of proving that you are who you say you are. And there are three categories of authentication factors. What you know, passwords, uh, PIN numbers and keys. What you have, things like smartphones with it has a known number or a smart card, or what you are. So that's biometrics, fingerprints, retinal scan, facial recognition, and so on. Technology for recognizing these things keeps improving, and many systems now allow you to log in with a fingerprint or a facial scan. But those are the three factors. Two-factor authorization has become common. So if you're like me, you get irritated every time you try and do something. They send a text to your phone. You got to check your phone. They have to remember the number. You have to type the new number in. Sometimes they'll let you copy it. Uh, but those are the things that are necessary in today's world to make sure that you are who you say you are. Okay, another part of authorization is called LDAP. So LDAP is a protocol. It's the lightweight directory access protocol, but it's embodied in a whole collection of tools. So your organization certainly everybody uses LDAP, I guess. So your organization uses LDAP. So what is it? It's a list of all the people with logins and passwords uh, that are eligible to use the systems of your organization. So if you're Carnegie Mellon, then you have a variety of tools that are available to students. You have another set of tools that are available to the faculty. You have another set of tools that are available to various staff members. And everybody has a login ID. I'll talk about the tools and the availability in a minute. But everybody has a login ID, and the login ID is kept in the LDAP. And the virtue of the LDAP is that when a user signs on to a registered system, the credentials are sent, the system sends, so your organization has a set of systems and you want to use one. So it asks for a login. and you give it your credentials. The system sends those credentials to the LDAP. The LDAP comes back and says, yeah, you're a valid user or you're not. And the virtue of an LDAP, or one virtue of an LDAP, is that it tremendously simplifies the process of putting new employees onto the system or removing employees from the system. So you are a new hire in a particular organization, you're assigned a login and a password, or you give it your password. However, the organization decides that's stored in the LDAP, and the organization doesn't need to worry about that anymore. Uh, Similarly, if you leave the organization, then you remove the login credentials from the LDAP, and you can't use the organization's system anymore. Associated with the LDAP is something called a single sign-on. So you sign on to one of the systems within the organization. Okay, if it's Carnegie Mellon, maybe you're using the Carnegie Mellon Zoom system or Zoom Access. And you then want to use a different uh, system. So again, if you're Carnegie Mellon, maybe I want to give you a grade. And I don't want to have to sign in again. I already just signed into Zoom. It should know who I am. Well, that's the purpose of single sign-on. It identifies you, and it tells the second system that you tried to log into that you're legitimate. So how does this work? You sign into a system, it gives you a token. Okay, and that token is stored. And now when you sign into the second system, you don't have to sign in, you provide the token. And the token is ephemeral. So that's a fancy way of saying it expires. And so you log in, you're given a token. Somebody takes your computer after you leave your computer open. Somebody takes it after a period of minutes or maybe an hour, and tries to use the organization system, but the token has expired, and so they have to then log in their own on their own ID. So this token, where is it stored? Okay, that's one of the discussion questions. And then I told you what ephemeral means, why, and I told you what it's useful, so I answered the first discussion question. Okay, well, knowing who you are doesn't mean that you have the right to uh, do anything. That's authorization. So knowing who you are is authentication. Uh, Authorization looks very similar, but it's a different thing. That says you have the right to access certain resources or certain data. So it's the authorization process is the process of determining whether you have that right or privilege. And there are two ways of looking at it. You can look at it from the perspective of the resource. Okay, I am Zoom. Uh, I have a list of legitimate users, one of whom might be Carnegie Mellon. So I mean, the list can be not necessarily individuals. That's called an access control list. The other is to look at it from the point of view of the user. Uh, so as a user, you have certain rights. You can have what's called a capability list that specifies what rights you have. And the basic principle of authorization is that your organization has set up a set of rules that determine whether which categories of people typically within the organization have which rights. And these rules are independent of any source code. So if you're going to change the rules, you don't have to change the code. Okay, and again, to use the Zoom example, Carnegie Mellon has an account with Zoom. And so if you are a Carnegie Mellon, you use the Carnegie Mellon single sign-on mechanism when you want to get to Zoom, and you're given a token that Zoom recognizes, and that allows you to sign on. Okay. But the authorization principle is that you shouldn't authorize somebody for a access to a resource or data that they don't need to do their job. So that's called the principle of least authorization, least privilege. I'm sorry, least privilege, not authorization. And then maintaining that for a collection of individuals gets complicated. If you have a couple hundred or a couple thousand or even a 10,000, tens of thousands of employees, um, then you move to something called role-based access control. And what that means is that you assign the credentials based on the role that the user has. So back to the LDAP. In the LDAP, you are assigned a role. Again, in the Carnegie Mellon context, you're a student, you're a teaching assistant, you're a faculty, you're a staff member of a various type, and that's your role. And then the credentials are managed based on the role. So you want to have a credential to get at a database. What is your role? What is the credential? Do you have the right? You go and get again a token. We'll talk about that in a minute. And you provide it to the database, and it says yes, you have the right to have access. Okay, if you change your role, it becomes a matter of changing it in the LDAP. It's not a big deal. So you are a student and you become a TA. Well, now you have two roles. One is student, one is TA for a particular course, and that is entered into the LDAP. And then your TA-ship is up and it's taken out of the LDAP. So that simplifies the administration of these kinds of things. So what are the problems with role-based access control? One is you're going to have an explosion of roles. So I use the example of a bank manager here. Uh, what size loan can you, as a bank manager, authorize without referring it to some other authorization mechanism? Well, it might depend on where your bank is. If you're in New York City, it's probably bigger than if you're in Millersville, Pennsylvania. And I'm sure you don't know where Millersville is. I don't know where Millersville is. I knew somebody that came from there though. And so you end up getting very segmented types of roles, and you may have lots of roles. Another problem is that the same credentials are applied to everybody in your category. So you have a credential to access a database. You quit or you're fired. Well, what happens to your credential? Okay, you still have it. Other people have that same credential. How do you manage that? And so there's a process called rotation where you periodically or on events change the credentials associated with a particular resource. And that introduces a problem of how do the people that are in that category get their credentials changed. And so that gets reasonably complicated. First, there's something called OAuth, which is a, a standard solution. There's also single sign-on, and there's a credential management system. And I'll use the example of Vault, which is an open source credential management system. So to start with OAuth, there are 4 roles associated with OAuth, and these roles are not the same as the roles in our role-based access control. There's the resource owner, there's the resource server. So the resource owner is a person, although it could be a service, that owns the resource and is responsible for giving access to it. The resource server is the piece of software or hardware that hosts the resource. And I say that twice. The OAuth client is a piece of software that wants to access a protected resource. And the authorization server is the one that sort of organizes all this and says yes or no. And if you look at the picture, what happens is you as the resource owner uh, tells the resource server, what category of people are allowed to access it. You as a client come in. If you have that 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 right, then you're given a token. If you don't, then you're not. And again, that gets reasonably complicated in managing it, and especially if you start to think about problems of rotation or leakage of credentials, and that's where Vault comes in. So a credential is anything that can be used for authentication or authorization. And Vault is a centralized credential management system. So it encrypts all the credentials, and the individual systems ask Vault whether a user can be given access or not. So they delegate the responsibility for saving and retrieving the credentials. It provides access control, so you have to log into Vault. Uh, it provides an audit trail. Who has accessed which credentials? So if there's a problem, you know who to point the finger at. And it allows you to rotate credentials since the system asks Vault to give me the credentials, you can change it, and people don't store their own credentials. They store it in Vault. And so this is a centralized function, and you can put together single sign-on, OAuth, and Vault. Uh, and by having the resource server from OAuth register with Vault, it's one of the systems that lets its credentials be managed. Uh, a system that's a client also registers with Vault. An individual can store their token in Vault. Uh, a client can use OAuth to request access to a resource, given a token, and stores it into Vault. And then the client retrieves the token when it's time to use it. Uh, Vault, because Vault has its own sign-on mechanism, it verifies that your credentials allow them to the token, and it returns the token to current access control, and then the client uses the access control. So these three things that we talked about, SSO, OAuth, and Vault, work together. And again, SSO depends on LDAP, so there are really four kinds of things that work together. Now, again, offline discussion. Suppose entry to a secured area is controlled by a keypad. How is this affected when the individual who has access leaves the organization, especially if they're fired? Okay, so a keypad is you have to know a number to put in. Okay, you have to tell everybody. Those are discussion questions. And then why is a centralized credential management system better than allowing the applications themselves to manage the credentials? I'm clearly advocating that it is. The question is why? Okay, so let's now talk about DevSecOps. So on the one, so DevSecOps is standard DevOps plus security. On the one hand, this is nothing new. Security has always been a part of DevOps. Um, the purpose of putting sec in it is one, marketing, and secondly, to call attention to people that security is in fact an important thing. And it has had some impact. Okay, so there are a number of tools and processes that have matured since it became DevSecOps. Authentication and authorization services have matured. Monitoring of individual microservices and various types of logging have matured. Secure communication between in Kubernetes uh, is something that's happened since it became DevSecOps instead of DevOps, and so on. There's a list there. Uh, and then that's the essence of that's the end of this chapter.